Hey guys, I'm Abhimanyu Banerjee, a computer science student from BENNETT University, and today I'll be sharing my experience of my summer internship, where I did it, what all I learned, and what all I did over there. Let's see. I did my summer internship at NRSC-ISRO, which is a prestigious institution in India known in the field of space and research. NRSC is an institution National Remote Sensing Center at Hyderabad, which is known for its work in receiving satellite data, generation of data products, and dispensing remote sensing applications and various other geospatial services. I did my internship in the month of May under the guidance of Dr. Jaya Saxena, and it seemed to be a very nice learning experience over there under her guidance. There are some real world problems that we face in remote sensing data, and one of the problem is the clouds. We seem to have observed that clouds cover most of this remote sensing data images, and which actually, in turn, the cloud actually obstructs the ground level data, the actual ground level data that needs to be processed. And this in turn makes data processing and analysis difficult in situations like natural disasters. For example, if we have a situation of there's a wildfire in a farm and the crops have been destroyed, and the government wants to analyze what is the level and extent of destruction happened. Now, in order to analyze that, we need proper data and not data covered with clouds. So, in such situations, cloud removal and ground level data extraction becomes a very critical part. Also, in our traditional deep learning algorithms, we need a huge data sets for our process of learning. But in case of remote sensing data, we might not always have temporal data for the same scene and for the same time and cloudless images available to us all the time. So in order to reduce the dependency on temporal data, uh, we are trying to come up with a different solution in our research project. Our approach and methodology. So the first part was creating a custom cloud masking. In contrast to the original implementation of deep image prior, they used a random masking, but for remote sensing data to identify where the clouds are, are the pixels which represent the clouds and masking them is the first step. That is creating a custom cloud masking. For this, CF mask algorithm and Landsat quality assessment band has been used, in which populates cloud confidence, shadows, snow, ice pixels in the satellite imagery to create a custom cloud mask. Then comes image in painting, reconstructing the image after the masking has been done. For this, we use deep image prior. In order to reduce the dependency on temporal data, deep image prior algorithm has been used, in which the network structure itself captures image statistics prior to any sort of learning. So what is the satellite images that we have used? The data source is Earth Explorer and the Landsat 8 collection 1 level 1 images that we have used. The images are of around 7,000 cross 7,000 pixels of size .tif images, which we have scaled down to 512 cross 512 pixels, and we have used four bands, namely band 2, 3, 4 for RGB and QA layer band. And the bottom we have shown all the four images that we have used for our research, which have been obtained from different geolocations, India and abroad. So coming to the project timeline, I first started off with exploring remote sensing data and the literature survey that had to be done. Then came the task of cloud masking and deep image implementation. Then hyperparameter tuning, optimizing all the parameters and customizing them for remote sensing data especially. Then I explored various architectures that can be used in deep image prior, namely UNet, ResNet, UNet++, FPN, and then I ended up with my final documentation. So here we have the results for cloud masking. As we can see, not only the cloud shadows also have been effectively masked and captured in our images. And now this can be further sent for processing into the deep image prior algorithm. Now here are the results which are very satisfying for deep image prior for our research, in which we have been able to successfully remove the clouds and reconstruct the ground image, ground truth level data. And the evaluation metrics that we have used is PSNR and SSIM. PSNR stands for peak signal to noise ratio to measure the quality of reconstructed image, and SSIM is structural symmetry index measure to measure the similarity between two images. So we have very nice results having PSNR value of 61.22 decibels and SSIM value of 0.99, which is really nice results to be achieved. And to end with our conclusion, this project successfully optimizes deep image prior algorithm for remote sensing data. This work implements effective custom cloud masking and image painting, even with scenes having cloud coverage area more than 50%. So we don't need to discard those images, and instead we can use it for our further analysis. The varied architectures used can have a strategic implementation based on use case and time priority in situations like defense and disaster management. I would like to thank you all for your time and have a good day.